Alessandro Volta, Nikola Tesla, Guglielmo Marconi, Alexander Stepanovich Popov. So what do these names have in common? Well, they're all scientists inventors, of course, but there's also something else that connects them. They're all winners of the IEEE Milestone Award, one of the highest honors in the field. IEEE considers unique products, services, seminal papers, and patents that are at least 25 years old and awards them with the title of Milestone of Innovation and Excellence. Some other inventions that received the award include the telegraph and the transistor, the internet, the laser, and magnetic resonance. Each of these innovations has an incredible story, and most of them are widely remembered as landmark discoveries in human history. But this podcast is not about them. It's about a team of people that developed a technology you probably never heard about, but that changed your lives in a very profound way. This is the story of STMicroelectronics, one of the world's leading semiconductor chip makers, and how they provided most of our go-to devices, and not only, with a smart way to manage the thing that is essential to every electrical and electronic device: electrical power. It happened in the mid-'80s, yet the prize was awarded in September 2020. Since May 18th, 2021, a plaque hangs in the entrance to the ST sites in Agrate Brianza and Conaredo, two small towns close to Milan, that commemorates this incredible achievement. This podcast hopes to do the same. This is the story of BCD technology, the story of a milestone of innovation and excellence. Human nature is distinguished by curiosity and eagerness to control, master, and transform reality. We could say that human history is basically a history of inventions and discoveries. Some of them are remembered and celebrated. Some are forgotten. Some have a huge impact on our lives, and we don't even know their name. This is BCD, Behind a Creative Disruption from STMicroelectronics, a one-episode podcast that will tell you the story of how BCD technology changed the world of technology forever. Very few people outside the world of microelectronics are familiar with BCD technology, even if it's almost everywhere. Cars, domestic appliances, smartphones, printers, medical devices, factory machines, and the list goes on. Probably most people could not even guess what BCD stands for, and I'll get to that soon. It shouldn't come as a surprise then that ST has already developed 10 generations of BCD devices, selling 40 billion units in 35 years as part of their broad portfolio of products. And the technology is constantly evolving. The way BCD devices work is pretty complex to understand for someone who doesn't work in the field, and their development has been a real challenge even for expert engineers and technologists. But this is definitely a story worth telling. Why? Because yes, it's about electronic engineering, chips, and circuits, but ultimately, it's also about teamwork, vision, passion, and courage. And these are universal values. So let's start from a simple fact. Every electrical device needs power to function. Your computer, your washing machine, your coffee maker, but it doesn't stop here. What we really want is the power to be managed in a smart way. So what does that mean? Well, smart can have a number of meanings, and in the case of the smart power that I'm talking about here, it means all of them. First of all, smart means power efficient, managing the power for the device in a way that minimizes the power consumption. We don't want our phone to run out of battery in 2 hours, or our electricity bill to suck up half of our income. Also, we might want to do our part in reducing energy consumption and fight climate change. Smart also means optimized control. For example, a motor that runs to produce the best results in terms of user experience and longevity of the device. In other words, we all want our washing machine to last longer. That also means being able to sense what is happening with the device and adapt the way that power is delivered. Now, how is BCD able to be smart? Well, the answer lies in the combination of three technologies of microchips that make up BCD's name: bipolar, CMOS, and DMOS. Before getting into this, let me state a fundamental difference, the one between analog and digital. What is analog? The real world, as far as we know, is analog. Human beings are analog. We understand reality thanks to analog signals, and these signals come from continuously variable physical quantities. For example, the light our eyes perceive is a form of moving energy made of microscopic particles called photons, and these photons move in electromagnetic waves. The sound of my voice that you're hearing right now is coming to you in sort of the same way. Not too long ago, when every innovation was mechanical, analog inputs were all we needed. But the digital revolution changed it all. The world of computers is digital. Computers generate, store, and process information thanks to a couple of bits, 0 and 1. Everything is processed through a string of code made of zeros and ones. Okay, so let's go back to our BCD devices. As I said, one part of BCD is bipolar technology. This means it takes analog inputs from the device it's powering and its environment and converts them into digital. For example, it can measure the amount of electrical current the motor is using at any instant. Next, we have the CMOS technology. That's the brain of the chip. CMOS technology is designed for creating digital circuits that allow the thinking functions. This is like in a computer, except the brain in each BCD chip is specially designed to have just the right amount of processing power and memory to be able to perform its function optimally. Then we come back to bipolar technology to create an analog output from digital data in order to control the power part. And finally, we have the DMOS, which makes the parts of the BCD chip deliver the power to the end device. At this point, you may wonder, if this BCD technology is just putting together pre-existing technologies, where is the brilliant intuition? Well, in order to understand how BCD technologies came about and changed everything, we need to go back to a time when STMicroelectronics had not yet been formed. I'm talking about the 80s, more specifically 1983, and a company called SGS Microelettronica. SGS then merged with Thomson Semiconductor from France to form STMicroelectronics in 1987. Until BCD devices were invented, building an electronic circuit capable of managing electrical power required a separate bipolar or CMOS chip to collect the input signal, depending on whether it was analog or digital, and a DMOS chip which instant by instant would allow the correct amount of current to pass. Very often, all three types of chips were required, and the chips had to be mounted on a board one by one with the right connections. The result was a relatively large circuit, not always reliable and quite expensive. That's why several people started thinking that it might be a good idea to create a chip that integrated all these three functions in a single package. Although the idea may seem obvious and logical to us now, there were two huge problems. Firstly, when placed too close together, the three components interfered with each other. Secondly, the power part generated too much heat and it ended up burning out the whole circuit. These were not trivial issues at all, and they were giving electronic giants such as Motorola or Phillips a lot of headaches. History of mankind teaches us that where some people see a problem, others, luckily, see a challenge. They are willing or even thrilled to take it. This is exactly what happened when Bruno Murari, then R&D Director for the Bipolar Technologies and Integrated Circuit Design Division, was confronted with the problem. He was in Castelletto, one of the two SGS's headquarters, when he enthusiastically said, "Okay, let's give this a try."
At that time, we were very successful with bipolar technology for audio amplifiers. But we had realized that our technology could be not enough to meet some of our customers' challenges in the near future. The idea to combine bipolar technology with CMOS, with DMOS, which we ultimately called BCD, came from these considerations. At the time in SGS, we had all competence and the knowledge, but in different organizations.
So in 1983, Bruno Murari brought together two teams. The young researchers who had developed the family of DMOS discrete power components in Agrate, and a group of researchers from Castelletto who had invented and produced the integrated bipolar power circuits. It was a perfect blend of the necessary skills needed, and it was also an unusual move. The Process Development Group in Agrate created the integration of the technological platform, enabling the three components, bipolar, CMOS, and DMOS, to coexist on the same chip. Antonio Andreini, Claudio Contiero, as well as Paola Galbiati, an expert engineer who still works for STMicroelectronics, were three members of that group. Let's hear what Galbiati has to say about those early days.
I was assigned to the BCD development team, bringing my limited experience and my willingness to address this new challenge. The activity was so innovative and people involved so few that roles and positions were very flexible. All team members could and were expected to contribute to each and every aspect of the idea. And as a matter of fact, that informal synergies was fundamental to our work and success. Every day we faced new challenges, new technical problems, new customer requirements, new application requirements, and new organizational requirements. And all was new.
Next to Galbiati, Andreini, and Contiero, there was a group of integrated circuit designers whose task was to understand the architecture needed to put together the three components and achieve the desired performance. This group included Carlo Cini, Claudio Diazzi, and Domenico Rossi. Plus, there was a group of technologists charged with the task of understanding how to develop the necessary technologies with the available equipment. Its members were Franco Bertotti, Ubaldo Mastro Matteo, Mario Foroni, and Paolo Ferrari. Except for Bertotti, who was a few years older and already known as a magician of manufacturing processes, the others were all very young. But under Murari's guidance, they learned to work together as a single multidisciplinary team.
The first important move was to concentrate all the extraordinary talent in one team. Once we recognized the exceptional talent and expertise of our teams and the strong needs of our customers, our task was very, very precise to get the power, to get it along with the logic, and to get the bipolar all together. We maintained the bipolar for its low noise. We made a trial using existing tools that were available in that period of time at our site in Castelletto. We knew that our colleagues in Central R&D had built a discrete component in DMOS with a V-shaped gate that could largely overcome the existing power limitation of bipolar. We decided to merge the three components, the bipolar, whose development we had been leading for years, the CMOS technology, and the new idea of the V-gate, the most power component.
After forming this special team, with all the enthusiasm surrounding those first moments, years of hard work followed. The young engineers searched for and devised solutions to the main BCD issues, which were avoiding interference and dispersing heat. But they also addressed a lot of other big and small issues. Their almost tangible mental effort was only interrupted by Murari, who'd often shout down the lab, "Hey, I've got an idea!" Or by Bertotti, the problem solver, who'd descend like a guardian angel on the team anytime there was an obstacle to overcome, and there was no limit to creativity. Let's go back to our timeline. We're in 1984. The team proceeded quickly, and the first chip worked quite well for several reasons. One was because of the low noise of the bipolar transistors. It amplified the weak analog input signals. Another was that the CMOS component handled the logic and the control functions well, and later included programmable memory. And still another was that the DMOS component enabled the chip to supply the high power needed. All this technology is stored in a tiny piece of plastic along with other materials, with admirable reliability, great energy efficiency, and a significant drop in costs for consumers. The first generation of BCD devices included chips for audio applications and chips for the latest Olivetti electronic typewriters. That market soon collapsed under the pressure of new personal computers. In the following years, hard disk drives and many types of applications would show up, demanding exactly what BCD could deliver. The real Eden for chip producers, however, was the automotive industry, where cars started having ever-increasing electronic content. One piece at a time, starting from the electronic ignition, the entire car was colonized by BCDs, and now a single vehicle can have several hundred BCD chips. But you may wonder, how does a BCD work in a car? Well, as any other BCD. While microcontrollers are the brains of every smart technology in a car, airbags, ABS brakes, electric windows, and so on, BCD optimizes the power consumption for each and every action. Today, each new generation of BCD chips is created in an integrated model, so that research and production work closely together, ensuring that the manufacturing process guarantees the highest performance possible in terms of volume, quality, and reliability. Each new generation starts off in one production facility, and once mature, production can be extended to other factories. The team today works on multiple generations that are in different phases, from concept to production ramp-up. I already said this at the beginning, but it's worth repeating because the numbers are impressive. In 35 years, ST has sold 40 billion BCD chips. And now, every year, over 3 billion BCD chips come out of the factories in Agrate, Catania, and Singapore. Today, any technology that needs electricity to function needs BCD chips. And the more sophisticated they become, the more applications they find. They're in cars, electric motors, lighting systems, video game consoles, printers, televisions, displays, motorbikes, e-bicycles, scooters, domestic and industrial robots, smartphones, chargers, medical devices, airplanes, satellites, and wireless chargers. This list is not even close to being exhaustive, also because the range of applications continues to evolve. We asked Orio Bellezza, President of Technology, Manufacturing, and Quality, which skills are required to be able to manufacture the ever more complex next generations of BCD technology.
Many flavors of technical and scientific competencies are required in this state-of-the-art, fully digitalized, Industry 4.0 enabled, and environmentally sustainable plant. On top of semiconductor fabrication expertise, we will need competencies in advanced automation, process control, data science and analytics, highly automated utilities, environmental management, and others. This is a great example of how a very successful technology, requiring a strong manufacturing base, is driving innovation in multiple fields of knowledge, as well as contributing to jobs and wealth creation in the areas where we operate.
We could say that BCD devices have silently conquered the world. They've become unknown heroes of technology and innovation, lowering costs and power consumption and delivering high reliability. This is Giuseppe Croce, Smart Power Technology R&D General Manager, on what challenges BCD device developers will face in the future.
Two major challenges are in front of us. On one side, a technical one. The historical evolution towards the next technology node creates major technical challenges in the scaling of power and analog stages, given the increased sensitivity of more advanced baseline CMOS platforms to any process flow modification. On the other side, there is a cost optimization challenge, which has always been a key driver for the BCD roadmap. As in the past, innovation will drive the evolution. Our capability to identify, develop, and release innovative and differentiated solutions to address customer and application needs in a timely manner will be key to sustain the future growth of ST Smart Power Technology roadmap. To make this happen, the continued integration and close collaboration of technology and product R&D and manufacturing teams remains a key asset for the future success.
We are now at the end of our journey. I hope I kept my promise in simplifying these complex concepts for you. But what I really hope you'll take home after listening to this podcast, even more than how BCDs function, is their disruptiveness and the passion and tenacity that was needed to build them. There's only one question left then. Why STMicroelectronics? With all the competitors out there, what made ST so special to the point of developing this incredible breakthrough?
Why the goal emerging bipolar CMOS and DMOS on a single chip was difficult? It was very easy to excite the team of engineers we collected to work together. We realized that something this difficult requires a set of skills and genius that existed nowhere else, and that we were the only one to accomplish it. We were exceptionally well motivated by the challenge. It is rare that you can assemble a team of fantastic people with the complementary skills who are able to work all together all day and night long. I imagine it is like a magical choir singing together with one single voice and making the most extraordinary music.
Yes, indeed. I can hear the music. A symphony of talented, passionate people. If you listen closely, maybe you can hear it too.